Morning everyone who is not here yet. Yeah, so I got the email from the school saying that your Monday lecture will be moved to Wednesday. You all got it? You all got the notice? Haven't? Okay, so they say they will reflect the timetable update soon. So where do you guys check the timetable, the most updated timetable? Infoseed, right? So now you want to try checking lah. You all got some app thing, is it? Oh, from next week, still the same? Okay, then maybe wait for a few days. So in any case, I will make the announcement after it is confirmed. Yeah. So probably we'll have our lecture 1 hour after the 1 o'clock tutorial. That means after the tutorial ends at 1 o'clock, right? I mean like today, there's 2 tutorials back to back. So after the later tutorial ends at 1 o'clock, we will take 1 hour lunch break. Then after that, we will continue with the 2-hour lecture. So lecture probably from 2 to 4. Right, so we are going to do tutorial 4 first today. Before we will proceed on to the topic 5. Topic 5 we are almost completing. So tutorial 4, question 1 is trying to find the Laplace transform of the 8 functions given. Do I need to go through any of them? C. One C is that you just expand out and then perform Laplace transform. So your f of t can be rewritten as this is e to the minus t. Then if you expand this out, you're going to get t squared plus, so it's 6t, right? Plus 9. So once you see the e minus t squared plus 6t plus 9, right, this guy, then you can just multiply out to each of the terms and then you just perform the Laplace transform using S shifting. So the f of s, right? So you can see that it is really all the terms here being shifted in the S domain. So you really have to just recall that t squared, you take the Laplace transform, is 2 over s cubed. So this 2 over s cubed, you shift by minus 1. So you will be 2 over s plus 1 cubed, because it's s minus minus 1. Then plus 6. Then this t is 1 over s squared. So you're going to get 1 over s plus 1 squared. Everything got to shift, because everything is multiplied by the exponential function. Then the final one will be 9 over s plus 1. So you just manipulate the f of t function into something that is recognizable on the left-hand side of the Laplace transform table. Then subsequently, you can just apply accordingly. Oh, sorry, there should be a 6, because I multiply by 6. G, So 1g is a piecewise defined function, meaning to say it is defined for different functions over the different intervals. So you just need to rewrite into the unit step form using the unit step function. So this function, you have to turn on, turn off. So this guy, right, if you recall what we have gone through in topic 5, so in topic 4. So you remember the turn on, turn off thing, which is demonstrated here, okay? So therefore, this is the general expression that you will need to keep in mind. This guy is the general expression. So if you apply this concept here, then you'll be able to just write down the functions quite easily. Because your f1 is this guy. So really, then you just have f1, which is t minus pi, times unit step t minus pi. You see this is pi, what? So that means it will be t minus pi as well. Because you start the t minus pi function at t equals to pi. Doesn't matter. Doesn't matter. So because the function starts at t equals to pi or immediately after pi, I mean it's the same, okay? So therefore this guy is 0, then you just have to plus. But if this is a 0, then your f2 is 0, so you have to minus f1, right? So that means this is just a minus, because it's 0 minus. So you got to turn off. So turn off will be the same function, but you turn off at t equals to 2 pi. See that? So in a nutshell, you have to turn on the first function and turn it off after 2 pi. Because it says here that your function reduces to 0 otherwise, right? Which means that after 2 pi it will be 0. So hence you have to turn off the function that you turned on earlier. Can ah? Yeah, so if you get that, the comparison here. So then what you can do is to rewrite the second term, right, into the proper form. Because the first term is already in the proper form. So the first term no issue. But the second term got issue. Okay, this one is okay. Right, because your Laplace transform for the unit step is this guy, which is this one. So you need to have t minus a unit step of t minus a. So the first one is in the correct form. Okay, so you need the t minus a unit step t minus a. So this one okay, but this one not okay. This one minus a, but this one minus 2a. So therefore you need to rewrite. So therefore rewriting, you just have to make sure this is t minus 2 pi. But you cannot anyhow minus 2 pi, right? Because the original is minus pi, right? So the correction will be just plus pi. So that's how you so-called correct it in the proper form. So hence subsequently you can just do your transform. So the first transform, right, will be, so f of s will be giving you. So you can see that if you do it step by step, you have to recognize the g of t minus a. So the first term, this g of t minus a is g of t minus pi is t minus pi. So if that is the case, then you have to ask what is the g of t then. So it goes to show that g of t must be t, right? Because it's t minus pi, then the g of t minus pi is t minus pi, right? So g of apple equals to apple. So then you have replacing the apple by t, so then it must be the function t only. Okay? So then what is the big G of s? So the big G of s is just 1 over s squared. So then you just plug into here, so because this is your G of s. So therefore, you really just write it down as 1 over s squared, or e minus pi s times 1 over s squared. So that will be your first Laplace transform for the first term. Then the second term, right, you just do exactly the same. So you can see this is t minus 2 pi, this is t minus 2 pi, right? So therefore, without much fanfare, this is also 1 over s squared. Agree, yeah? Because this guy is g of t minus 2 pi. So therefore, g of t is also t. Then g of s is just 1 over s squared. So therefore, the second term will be minus of, put a bracket, then you have your 1 over s squared, then later on need to multiply by e to the minus 2 pi s, because your a is 2 pi here, okay, right? So then the last term, which is just pi, but pi is a constant, what? So if pi is a constant, then g of t minus 2 pi must be pi. So then the g of t is just the same. Because it's a constant. Constant everywhere means that no matter how you shift the function, you shift left, shift right, it's just a horizontal flat line. You shift, anyhow shift also the same number. What? So which means that the big G of s will be pi over s. So therefore you just have plus pi over s right here. So you see the usage of the t shifting step by step. So basically you rewrite first, right? Rewrite into the proper form. That's step 1. Then step 2 will be just for each individual term, just find out what is the big G of s by recognizing the small g of t. Okay, because small g of t, your Laplace transform will give you big G of s. That's the indication. So therefore, yeah, this one? Yeah. Huh? What 2? 2? Where's the 2? Or if there's a 2 here, is it? So your question is asking if I put a 2 here. Like that? Can also. Yeah, so then this one, if this is a 2, then this one have got 2, right? Correct not? So then the 2 will propagate all the way down. But if you have, like, let's say this is 2t minus pi, but you didn't, Because you want to have a function, right, that is in the form of t minus pi, correct or not? So therefore, you have to rewrite. So this is 2t, but you need a minus pi. So therefore, you got to rewrite. So you have, because it is 2t minus pi, right? So which means to say that you have to have, wait, let me see. So your 2t become 2 times t minus pi. So this t, you treat it as a so-called separate function from the minus pi function. Okay, because 2t minus pi, the 2 only applies to the t. So therefore, the 2t rewrite as what? Rewrite as 2t minus pi plus pi. This guy, you write it as 2t minus pi plus pi. Then this minus pi you put outside. Okay? This minus pi is this minus pi. Right? You put outside. So therefore, right, if you expand this, what you are going to get is 2 times t minus pi, which is in agreement with the unit step argument. Okay, then you can see that there's a what? There's a plus 2 pi minus pi. So then the net result is plus pi. Because you have a plus 2 pi, so this is a plus pi. Is that okay? I repeat the solution again. You see, if you have a 2t here, so how do you make the t into t minus pi? You just force in the minus pi. But you have to correct yourself. Okay? Because the original function is 2t, right? So therefore, you minus pi plus pi, right? But you want the t minus pi term. So you just take the 2 times t minus pi. Then you have a 2 times pi minus pi. So that will give you plus pi. Then you can do the transform accordingly. So it's always the same trick. Always the same trick. Any questions? Very good. So that will be for G. Any other parts you want me to go through? F? You mean F? So for part F, you can see that it is in the unit step function already, but it's not the nice form that we want. We need to have the nice form condition. So therefore, got to rewrite this again. So extending what I mentioned earlier in your response to your question, t got to change to t minus a. So you just perform the same trick again. So this is 2 times t minus 1 plus 1. Then unit step t minus 1. So you have to do that. Once again, it's because of the t minus a ut minus a thing. This is the requirement. So plus sine of t minus pi plus pi. So you see, I'm always trying to manipulate into the same form from the Laplace transform table. So therefore, if you look at the terms here, it's really in proper form, so then you can perform the Laplace transform already. Okay, but then the truth is this guy. You can see that this is a sine of t minus pi plus pi, right? So therefore, there is no direct Laplace transform for this kind of term. Okay? So therefore, this calls for the compound angle formula to help you, right? So if you look at your compound angle formula, you have to find something that fits this guy. So it looks like A plus B. So this looks like A and B. So therefore, you find someone that is looking like that, which is this guy. So you have to use the compound angle formula, sine A plus B, okay? So hence, you can rewrite this thing, okay? So I just kind of follow through. So this part, you'll write it as sine A cosine B, right? So it will be sine t minus pi cosine pi cos cosine B plus cosine t minus pi sine pi. But this guy you can simplify further. So therefore it becomes sine t minus pi times cosine pi, which is minus 1. So it's just minus sine of t minus pi. Okay, then plus sine pi is 0. So you see cosine pi is minus 1, but sine pi is 0. So actually the whole thing will become minus of sine t minus pi. Is that right? So which means that it conforms to the nice form already. So hence we are going to just take the inverse, take the Laplace transform. So therefore the big F of S is going to be, so you look at this term, right? It's going to be, oh, maybe I can rewrite this also. So you see there's an e to the square. So it'll be e square times e to the 2t minus 1 ut minus 1. So therefore the f of s will be e squared. There's a constant, just put it in front. Then this guy, right? As I mentioned, this is your g of t minus 1. Okay, I write out the steps because it is clearer for you to see. Okay, but if you are well versed already, there's no need to write out the step. You can just like go through the steps in your brain and then just write down the answer directly. Okay, that is totally fine. No need to write out all the like intermediate steps. Okay, if you can do it in your head. So the g of t is just e to the 2t then. So that means to say that the big G of s will be the shifting. So 1 over s minus 2. So then that gives you your result already. So you'll be e squared, this term, then 1 over s minus 2 times the e to the minus s. Because it's minus 1s ma. So that will be your first term. Then the second term is a minus sign, right? So you know that in your mind, this is your g of t minus pi. So if this is g of t minus pi, that means the g of t is just sine t lah. So therefore it has to be 1 over s squared plus 1. Then after that you have e to the minus pi s. Is that alright? Nope. This one is a unit step.
But what if I treat?
Makes sense. So if you treat the u as the g, but because this is g of t, this is g of t. So you want to treat g of t as this unit step. Can lah. Can. So that means that means this will be e to the minus. Okay, so your g of t is u of t minus 1, right? Can also. You'll get the same answer. Wait, you see. So let's say this one, right? Wait, you're talking about this one, is it? The earlier one, right? So you have what? E to the 2t, this one. Okay. So therefore you treat you use the s shifting, right? So this is your g of t, right? So if that is the case, that means your big G of s will be e to the minus s. Am I right to say that? No, because your g of t is this way. This is your g of t. So e to the minus s over s. No. You have to find g of t first. Then after that you shift this guy. So therefore, you understand? You see, this thing, if you use this, your g of t is this.
Yes.
Then your e minus e to the at is this.
Yes.
So then you get the g of s first. That means then your g of s minus a, s minus 1, will be e to the minus of s minus 1 divided by s minus, agree?
Yes.
So then this is e times e to the minus s times e to the minus s over s minus, is that right?
No.
Of a minus 1 e to the minus s, e squared s minus to the 2t away. Sorry, my bad. This should be minus 2.
Yes.
My bad. So then you get the same thing e squared s. Isn't this the same thing?
So
can also. Yeah. Can. Hold on, this one okay No. The thought process is you have to recognize this thing.
Yes.
So after you recognize this thing, in order to get the big G of s, you got to get the small g of t. Because the big G of s, right, this guy is the Laplace transform of the small g of t. So therefore your g of t minus a, you must get g of t so that you can get the Laplace transform for the big G of s. Yeah. Okay, so so this, I believe maybe some of you have the same question. Why do I have to get the small g of t? How come I can just replace the g of t minus pi by t, right, and then find the corresponding function? The story is in the Laplace transform table, this big G of s is denoted as the Laplace transform of small g of t. So now the thing is, your t function has the small g of t minus a, not small g of t what. So therefore, it means to say that you go and recognize this g of t minus a first. Then after that, just replace t minus a by t. So after you recognize this, right, basically just replace t minus a by t so that you can get this small g of t. That is the idea, okay? So that you can get the big G of S. Basically, we are transiting from the left-hand side of the table to the right-hand side. So we have to like find the corresponding terms so that they can give us the right-hand side. Is that right? Okay, good. So that will be for question 1. I think the rest you can try. Question 2. So question 2 is more of trying to let you practice on the integration process of the Laplace transform and also your S shifting. S shifting is due to this e to the t, but you can also do the derivative, which is on the t square. So this one I think I won't want to go through because I have gone through a similar question in the tutorial, in the lecture example. Any strong demand for me to go through? So DIY. Number 3. Number 3 is to find the Laplace transform function of this complicated looking expression. Do I need to go through? Yeah, so if you look at this expression, right, you got t, you got exponential, you got cosine. So it's really up to you whether you want to do the derivative property because there's a t there, right? So if you look at the Laplace transform table, let me get the Laplace transform table. So the t property or the derivative property is for this guy. Can you see this guy? So you compare apple to apple, right? Can see that there's a t and a t power n here. Then the g of t will be this entire term. The exponential times cosine will be your g of t. Okay? So you can make use of the derivative property followed by the S shifting property. But you can do the reverse also. You can do S shifting then followed by derivative property. Okay, so what I'm trying to say here is, okay, let me put it here, more space. So now you can see that which is the big G of t? Which is the small g of t? This small g of t must be this entire thing. Must be this g of t. Okay, right? So therefore, this is just t to the power 1. So n equals to 1. So this one quite easy. So n equals to 1. So therefore, if you write down the big H of S, you can actually write it down already. So big H of S must be minus 1 to the power of 1. Then G prime S. But you got to find G prime what? So therefore, in order to find G prime, you got to know big G first what? That's how to prime it. So therefore, you need to find the big G of S. So big G of S means, right, you recognize that the G of t, so where G of S must be Laplace transform of the small g of t. Okay, but then the Laplace transform of the small g of t, right, is just Laplace transform of the EKT. So Laplace transform of e to the kt cosine omega t. But if you Laplace transform EKT cosine omega t, then you just perform shifting, right? So cosine omega t is by right s over s square plus omega square. But you never shift yet lah, so you have to shift ma. Shift means what? The s become s minus k. So just put minus k, and then the s square become s minus k whole thing square. Just perform shifting, s shifting. Is that right? So you have successfully found the big G of S. Then you just plug the whole thing inside. So it will be minus of d ds. I write it as this form, the derivative form. And then you just plug this whole thing inside. So now you're going to differentiate this function with respect to S. Is that right? So how to differentiate that? Obviously you're going to use quotient rule. So you need to use quotient rule, math 1. So it will be a minus of, so hold the denominator, then after that minus the, hold the denominator, then differentiate the numerator, which will give you 1, minus hold the numerator, differentiate the denominator, which will give you 2 times s minus k, then divide by the entire denominator square. So therefore that should give you the answer given. So as it is s minus k square, this is also 2s minus k square, but it's a minus then minus. So which means to say that this is going to give you 2, did I mess up? This is 2 minus k or s minus k? Oh, this one is s minus k, not 2 minus k. So therefore this guy is going to be 2s minus k whole thing square. Then there's a positive, so minus minus. So become s minus k divided by that denominator, which I believe should be the given answer, y omega square. First part yeah, I forgot my plus omega square, my bad. Oh, okay, wait I forgot the plus omega square here, yeah. Okay, yeah, so let me try and simplify this. So it looks like I have s minus k square, so there will be a minus, oh yeah, then I need to add this part. So which means that it will be s minus k square, is that right? Yeah, s minus k square minus omega square divided by that denominator. Is that right? Is this legit? Thanks. Hence you observe that I did the s shifting first. You see the s shifting being applied here. Then derivative second. But you can do the reverse. If you do the reverse, you also get the same thing. Meaning to say, you do t cosine omega t. Then after that, you do the s shifting by multiplying the e to the kt. Okay? So this part is s shifting first. Then this guy will be derivative later. Okay? I put all here. Can also do derivative first and s shifting second. So this one you can try. Okay, so derivative first and s shifting second, effectively you are trying to find the Laplace transform of e to the kt times t cosine omega t. So you can see this t cosine omega t, you do derivative first because the t applied to cosine omega t. Then after that, the s shifting comes second because the e to the kt outside, but it's the same function, right? Okay, so if you do this, right, then you will notice that you get the same answer. Yep. What difference does it make? I think you do derivative first might be easier. Because when you differentiate, you want to differentiate a simpler function. So if you do the derivative first, that means you do this part first, right? That means most of the time you are applying the derivative, that means differentiating a simpler function. Then after that, your s shifting, just put all the s become s minus k. So therefore, I think derivative first would be easier. Is that right? Okay, good. So that will be for question 3. Question 4, I don't need to do, right? Do I need to do? Yes. Then I'm definitely not going to do question 5. Because question 4 and 5 like quite similar. Yeah, so this one, if you do integration and t domain, you will get the same answer. So do I need to do the integration part? Yeah, so the story here is, if you Laplace transform f of t, right, using integration, then you just integrate this f of t function, the e to the minus st dt, from 0 to infinity. But you got 0 here, what? Correct or not? So 0 from t equals to 0 to t equals to 2. This is 0 function, then 0 function you integrate also get 0. Okay, for definite integral. So therefore, you can simply just say that no need to integrate from 0 to 2. Start from 2 onwards can already. But from 2 onwards, you are getting the function t minus 1 square. Okay, then e to the minus st. Okay, 0 to 2 is a 0 function. So don't have to worry about that. It will be just 0. Then if you integrate this, then you just use your tabular form because you need integration by parts, right? So therefore you have your t minus 1 square. Then this one is 2t minus 1. Then this one is 2. Yeah, correct. Then after that you have 2, then after that is 0. So you just keep on differentiating until you get 0. Then the dv, it must be e to the minus st. So this one is minus 1 over s, then 1 over s square, then finally minus 1 over s cubed. Because you keep on integrating, then obviously the exponential function will still remain. Okay? After that, tie shoelace. So the plus, minus, plus, got to kick in. So then you can write down the expression, which is, let's put a big bracket, which is t minus 1 square. Okay, I'll factorize the e to the minus st out lah. Okay, because it's like a big hassle to write. Because every term also got e minus st what. So therefore I keep on writing it, right? So I might as well factorize it out. E to the minus st. Okay, can you see every term also got e to the minus st. So I just factorize all the e minus st term out. Easier to write that way. Okay? So then it will be t minus, oh sorry, this will be a minus. So it will be minus of t minus 1 square divided by s. Then after that is minus again. So, wait, correct. So therefore this is minus 2t minus 1 divided by s squared. And finally it will be minus 2 over s cubed. Then I have to plug in the limits 2 to infinity. Any objections? Yeah, looks right. Can Okay, so when the infinity come into the exponential decay function, it will make everything 0. Okay? Make everything 0. Even though your infinity go into the t here, right, you think you got infinity square. But infinity square or t square cannot grow faster than the decay rate of the exponential decay function. Okay? So therefore, it will still be 0. So this infinity here, right, is going to give me 0, then minus. Then you sub in the 2, the lower limit. So if you sub in the lower limit 2, right, then you are going to get e to the minus 2s. Then after that multiply by minus 2 minus 1. Minus of 2 minus 1 square. So therefore it will be minus 1 over s minus 2 minus 1. 2 over s square minus 2 over s cubed. Is that right? So then clearly if you multiply in the minus here, then you got all the plus here. Is that right? So integration is done. So now you use the t domain shifting property. So t domain shifting property will be the unit step definition. Okay? So this first part is by integration. So the next part will be by t domain shifting. By t shifting. So by t shifting, you have to rewrite the f of t into the unit step function. So clearly it will be just t minus 1 square times unit step of t minus 2. That's it lah. Because you only turn on at t equals to 2 what? This function. The 0 no need to write. But this one is not in proper form. So the g of t minus a, ut minus a form, right? Once again, we need to rewrite it in that manner. So therefore, you notice the same trick will appear. This t minus 2, then t minus 1. Then obviously you go and change it into t minus 2. But this is minus 1, so you have the plus 1. Then square. So once you have that, then you got the proper form nicely in place. But then you got a square there, right? So therefore you got to expand out. So just expand in terms of a plus b. So that will give you t minus 2 square. Let's put a big bracket. Plus 2 times t minus 2 plus 1 square, which is just 1. Then your unit step t minus 2 will be there. Is that okay? This one I just expand in terms of a plus b square. So this is like your a, this is like b. Then I think you can do the Laplace transform already. So the f of s, straight away write, don't want to write all the steps already. Okay, so this one unit step, right? Confirm got the e minus as term. So you just put big bracket first. This unit step is going to give you e minus 2s. Okay? You see, this one e minus 2s. So you want the big G of s already. So the big G of s, you do term by term. This one is like t minus 2 square, which means that t square. So t square will give you 2 over s cubed. Then this one will be plus 2 over s square. then plus 1 over s. I mean, accordingly. This one, do I need to write out the intermediate steps? Okay, good. So obviously they must be the same. Okay, can see here and here is the same. Any questions? So I'm going to skip question 5 because it's similar to question 4. Question 6. Question 6 is similar to question 4 and 5. I no need to do right. Okay, DIY. Question 7 and 8, I will need to go through. I think I will go through question 8 and then you do question 7. Because question 8 is harder than question 7, but they are the same kind of thing. Okay? Oh, okay. So this one you DIY. So I'm going to go through question 8. Anyone managed to do question 8? No? So in question 8, you have a periodic waveform. So they tell you the function is periodic. Okay? So the periodic function is comprised of a series of cycles. Then g of t is representing one cycle in 0, 2. So if I underline the g of t function, this g of t function, it is actually this part. So it's just repeating g of t. Okay? So g of t is comprising of a downsloping linear function together with a zero function. Okay? Between the interval 1 to 2. Right? In the interval 1 to 2. So, it is just a continuous repeating of g of t that defines f of t, right? So, which means to say that you can actually write down f of t in a form that is using the unit step function. Okay? So, let us write down f of t together. So, f of t must be equivalent to. So, you have to start g of t, correct or not? So that means it will be g of t times unit step t. Okay? That means you like activate or turn on g of t at t equals to 0. Okay? Then after that you have this function. Can right? But you get another cycle that kicks in at t equals to 2, correct or not? So you have to plus what? Then it will be g of t minus 2, right? Hold on, I have to make it like super clear. Why is this g of t minus 2? Because you shifted what? You shifted to the right by 2, So this is just g of t minus 2. Isn't it? You shift right by 2. So if you understand this, then obviously you got to turn on the fella at t minus 2. Can you see? Can? Okay? Right? And then you notice that, how come I never turn off this thing? No need to turn off, because this thing, right, later you define, this thing already turned off already, what? So you turn on here, you turn off here. So basically, this first part will become the 0 function after 2. In fact, after 1 is the 0 function. Okay, so no need to turn off, it turns itself off already, as you will see later on. Okay, because of this part. So therefore, I just turn on this at t equals to 0, turn on this at t equals to 2, but still got more, what? So therefore, you can see the pattern. So plus g of t minus 4. Turn on at t minus 4. Okay, then this one plus dot dot dot. Forever one. Because periodic. Then if you look at this expression, we can make it concise, right? Just write a sum. Sum of what? Sum of g of t minus. Now look at it, it's 2. 4, 6, and so forth. So it's just t minus 2n. Then this n start from 0 to infinity. Okay, just g of t minus 2n. So at n equals to 1, you get this thing. N equals to 0, get this. N equals to 1, get the second term. N equals to 2, get the third term, and so on and so forth. So maybe I write. So this one is n equals to 0. Then this one is n equals to, and so on and so forth. So therefore, times unit step t minus 2n. Because same thing, Following, So, what is the Laplace transform of f of t? Laplace transform of f of t must be Laplace transform of this big bunch. But the Laplace transform of a sum is just the sum of Laplace transform, because Laplace transform is a linear operator. So you just take the sum outside the Laplace transform. Then apply the Laplace transform to the inside. Linearity property. Okay, wait, I must copy and paste this one. See? Can I just make use of the linearity property. But, what is this? This is gt minus 2n ut minus 2n in proper form already, ma. So then, isn't that what we have been using for so many problems? So then what's the answer? The answer is the sum of e to the minus 2ns times big G of s. Is that right? But what's the big G of s? Fine. We haven't found it yet. Okay? Find big G of s. So you just have to write down G of t what? Okay? So to get, okay wait, maybe I do it here. To get big G of s, now you have to understand that the small g of t, right, is, so what's the small g of t? Small g of t is just this thing, g of t. So g of t is, look at the gradient, mt plus c. So the gradient is just minus 1. So it's minus t plus 2. Legit. Okay? But the small g of t, you turn on this minus t plus 2 at t equals to 0. But you must turn it off. Agree? So therefore, this guy is ready for transform, but this guy is not. But you can just, write it such that it is, right? So you see, if I rewrite this properly, I'll get 2 minus t ut. So you see the t minus 1 here, you want to have a t minus 1 here as well. So therefore you have a plus, plus, take out the negative. So then it will give you t minus 1. So by this is t minus 2, so you have to put a minus 1 again. Okay, so if you look at this part, right, take out the minus. If you take out the minus, it becomes t minus 2, right? So t minus 2 is just t minus 1 what? Can, So therefore now straight away do the big G of s ready. Yeah? Yeah. This one no need, this one ut. This one? No, because this one is t, it's not t minus 1. That means the t minus a, this one no need what? So you just treat them as separate functions already. So therefore the big G of s can do Laplace transform. So you're going to get the ut here, so e to the 0s, no need to write. So straight away just write 2 over s minus 1 over s square. That's your first term, plus. Then this guy, t minus 1, so become 1 over s square minus 1 over s, e to the minus s. Is that right? Any objections? So you found G of s already. So if you found G of s already, then just write down the answer. This one I changed color. Is that okay? Any questions this part? Because there's actually two Laplace transforms. There's two parts. One is the f of t function. The other one is the g of s function. The g of t function. How do I form this? Here lah. How you get g of t is just, this first part is just 2 minus t ma. But 2 minus t you activate at t equals to 0. Correct or not? Then this part is just 0 function. So you have to minus away the 2 minus t function, turn it off. So this one you turn on 2 minus t, but you have to turn off 2 minus t at t equals to 1 what? Correct or not? This one you turn off here, turn on at t equals to 0. Then turn off at t equals to 1. Is that right? Any other questions? So this question 8 is done. Okay, last question, which is the past year assessment question. So this one, I think I no need to do, right? I can do. Okay, maybe I mark attendance first. You DIY first a little bit, then I'll go through in a bit. Let me mark attendance. Alexander, Aliyah, Emelina, Angelico, Jiashon, Brian, Chen Chang, Zhen Yi, Ivan not here. Oh yeah, he might be in a later class. Yang Ing, Emilia, Erwin, Yanjin, Zhan Yang, Dongbin, Noritetsu here, Javier here, Joey here, George. Jordan, no. Kayla here. Kevin, Ken Leong, Sharon, Dawson here. Chen Ying here. Jonathan, no. Kun Yong, Mac, Mikhail, Mohan, Azari, Danish, Irfan, Naya here. Bing Jie, no. Bing Jie. Keng Hong, Zixuan, Fadila, Phoebe, Yan Heng, Sherwin, Benjamin, Raymond, Reese, Rugina Tanalai, Jumpang. Okay, those are the afternoon. Jerome, Sean, Justin, Hao Po, Ryan, Sohadi, Johans, Wei Yi Chong, Tianzhen, Trisha, Yang Hong, Shi Kang, Xingzi, Zotet, Zumpin Wai. Okay, so let's finish up. Maybe I'll just finish this question and end the class. Okay, so this is telling you not to use integration, just use the table accordingly. But you see a bunch of terms, so therefore you can apply the various Laplace transform properties to each and every term accordingly. Okay? The problem is, okay, this part no problem, this one just S shifting. The problem is this part. So therefore, let's rewrite. So this first term, no issue. Okay, we don't need to do anything to it. This part, you have to rewrite. So you have your t plus 1, but this is t minus 3. So you got to make it t minus 3 plus 4. Why plus 4? Because you got t plus 1 what? So if you force in the minus 3, you obviously have to plus 4 back to get plus 1 here. Just like kind of make it the same. So the unit step t minus 3. Then this part, right, you're going to rewrite because you need to expand the square. So hence it becomes t minus 3 square plus. So 2 times 4 times t minus 3. 8 t minus 3 plus 16. So the unit step remains. Any objections? This part, any questions? No questions, then ready for transform. So the big F of S is just, this one do shifting, S shifting, correct? So t cubed, so n equals to 3. 3 factorial over S to the power 4. Okay, but you have to do shifting lah. So that means, okay, this guy will give you 3 factorial over, okay, the Laplace transform. So this guy, right, if you do Laplace transform, then you will get 3 factorial over S to the power 4. Then the cosine function will obviously give you S over S square plus 25. But you got to do S shifting what? So therefore, you will get 3 factorial, which is 6 over S plus 2 to the power of 4. That's your first term. Then after that, same thing apply to the cosine term. S plus 2 over S plus 2 whole thing square plus 25. Can? So you're going to do S shift after you Laplace transform. Then the second term here, right? So therefore, it will be a bracket. Then the unit step will give you E minus 3S. So this one is what? T square. So T square is 2 over S cube. Then this one 8T. So 8T is just 8 over S square. Then 16, constant. So then you get K over S, which is 16 over S. That's it, this is the answer. Any questions? Any questions? So we've ended the tutorial 4. So please try the rest of the question on your own if you have not done so. Later in the afternoon, you will get your midterms back. If you don't want to check, it's okay. You just delete the email. But you will receive the email notification from Gradescope. You all know Gradescope, right? So then you notice that the total marks is 76, but it is only upon 70. Okay? you'll see like the total marks, right? Maximum marks is 76, right? Because I mentioned that there's 6 bonus marks, right? Yeah, so whatever marks you get, let's say you get 65. You just take 65, divide by 70. That is your percentage of the score. Okay, then you can check in the grade scope and see where you got deducted marks. If I didn't deduct correctly, you can come and look for me next Wednesday. Then why next Wednesday is because your lecture on Monday has been successfully shifted to Wednesday, but it might not have been reflected in the info sheet yet. Okay, so this one, once it is reflected, confirmed already, I will make announcement, but you can check your info sheet timetable to see if it's updated already. Yes? Javier, this one later. Okay. Any questions? No class, Monday no class already. So, because Monday lecture has been moved to Wednesday. So, Wednesday, the lecture, I think, they shifted it to 2 p.m. Because the tutorial, by right, there's a second tutorial after your class. So, that will be ending at 1 p.m. 1 p.m. go for lunch, 1 hour, then 2 p.m. start class. So then 2 to 4 lah, so 4 o'clock, end of the lecture. Is that right? Okay, so for those of you who have no questions, you can leave already. Yeah, I don't know. We have to look at the venue. Okay.